All right, so in this video, I'm just going to talk about some of the basics of the unit circle. Before I even get into the topic, I first off want to stress the importance of this thing. I know it's going to seem easy right away. We're going to delve deeper into it, but it's important because it's used in subjects. A lot of physics uses this idea of the unit circle. Our real number system is even based upon this idea. Um, when you think AC current, those are actually waves. That we're going to get into waves. That's related to this concept. So there is very much so an important reason to learn this subject here. So let's get into the unit circle. Okay, I just wanted to first off stress the importance of this thing. Whenever we talk about the word unit in math, that number is it's not a trick question. 1 unit, it's 1. It's 1. Unit refers to the number 1. And in context to circles, you can start thinking, well, why would we talk about the number 1 for circles? What's important about a circle? And instantly, I think the radius is important. When you're talking about circles, that's an important thing for a circle. And the unit circle does have a radius of 1. It is defined to have a radius of 1. Now the question is where is the circle drawn in space? I mean, it could be drawn here with a radius of 1. It could be drawn here. But right here, that is said to be the center of this thing. It's right in the center of our x and y axis. That point is the origin, so it looks like this. My circle's not perfect, but that'll do. All right, so this point is 0, 0. Now, right away, I'm going to point out, you can see 1, 2, 3, 4 points on this thing. We can figure those out. Because the radius of this thing, if we're going to measure that length right there with a ruler, that would be 1. So we're looking over here. That's 1 unit. That's 1 unit. That's 1 unit. Going counting 1 unit down. So that's the radius of that thing. Now, if you consider that point 0, 0, and we consider this point right here, and we want to figure out what that value is right there, we're just going 1 unit over in the x direction. So that point would be 1. We didn't go up or down in the y-axis, so it'd still be 0. So at that point it would be 1, 0. Also, if we're looking at this value right here, and we're wanting to figure out where that lies on our circle here, it's not going anywhere in the x direction, so it's 0. We count 1 unit up, so that's point will be 0, 1. Now let's look over here. All right. If we look at our x value here, this value would be -1. So this would be -1, and then we didn't go anywhere in the y direction, so it would be 0. And then lastly, it doesn't go anywhere in the x direction, so that would be 0. And how far do we go down? You know it's going to be negative because we're going down. This is the negative region for the y, so it's 0, -1. So we already can find 4 points on this thing. We're going to find more points later on. Now, I want to talk about the circumference of this thing. Think about what is the circumference of a circle. What's the equation, first off? I hope we all know it. It's 2 pi r. Okay, so the circumference of a circle is 2 pi r. The radius of a unit circle is said to be 1. So, in other words, we can ignore r because that number is just 1. So, the circumference of this whole entire circle is said to be 2 pi. So, that is an important concept right away. So, from this concept that this circumference, the length around the outside, we can relate this concept to radians and degrees. So, we get this kind of relationship building here. When we first start talking about the circle, we always talk about, there's a fancy word for it. I don't really care so much about the word. We call this the initial side. This is our reference point. Okay, so we call this the initial side. So right here, this is our initial side. Okay, so that from our center to the point 1, 0, that side is called the initial side. There's a fancy word for it. It's important because of this. When we think about our quadrants, this is our first quadrant, second, third, fourth. People are like, well, where did those numbers even come from? It came from this idea right here. If we're going around our circle here, what we're going to say is that if I start from here and I go all the way over to here, that measure, in terms of degrees, that would be 90 degrees. So let's call this right here, let's say that this is 90 degrees over here. So we're going from here to here, that would be 90. If we went from here and we continued, oh, sorry, I hate that noise. If I went from here and I continued, kept going, all right. So if we started here on the initial side and we went all the way over to here, that would be 90 plus 90. So that clearly would be 180. That's a straight line. So that's 180 degrees. All right, let's keep going a little more, adding another 90 degrees over here. So if we started from our initial side, everything is in reference, it's in context to the initial side. This side over here is said to be the terminal. It's where we end. We're going from our initial side here all the way to our terminal side over here. It'd be, well, that would be 180 plus another 90 degrees would be, that must be 270. Okay, so this is an important one too down here. This 270 degree mark right here. Let's keep going. We go all the way back around. So we go all the way back around. That would be 360 degrees. You know, you spin on a skateboard, you do a 360, okay? That's what it is. You start from here, you end up back around on it. That's the same concept. When you spin like that, you start at a point and you end back around on it. Now, the other thing is that when we start here, this angle is also 0 degrees. 0 degrees, 360 mean the same thing pretty much. Okay. Now, okay, here, I'm going to erase this. So we kind of already know from our geometry backgrounds that this is all in context to degrees, but we don't know it in context to circumference, you know, radians. That's what this whole concept is built upon. So if we consider these values instead of in terms of degrees, we can think of them as in terms of arc length. And that's what's important about this concept. So from here, you know, going all the way around, so we went all the way around, we know the circumference of that would be 2 pi. So right here, instead of writing 360 degrees, that would be 2 pi rad, 2 pi radians. So this would be 2 pi. And then since this length all the way around our circle would be 2 pi, the upper half of our circle, that would be half of 2 pi. So 2 pi divided by 2 would be pi. So this would be, instead of writing 180 degrees, that would be pi radians. A lot of people, they just define it to be like this, to be, instead of writing 180 degrees, we just say that's equal to pi radians. And then, so if this is pi radians, so we went from here to here, and then if we consider, this would just be half of it again, because we're cutting it in half. Think of this arc length from here to here, and then think of this arc length from here to here. That's just half of it. So this is pi, so this must be pi over 2. So instead of writing 90 degrees, we could write that as pi over 2 radians here. Here, I'm going to erase this so that way I just don't get that. All right, so this is, okay. All right, so this would be 0 degrees or 0 radians. This would be pi over 2 radians, plus another pi over 2 is pi radians. So this is our pi radians over here. And then plus another 90 degrees, in other words, another pi over 2. So this is pi, plus another pi over 2 would be here. So in terms of radians, we want to figure out what this is down here. So I'm going to write off to the side here, scratch work, scratch. We're trying to figure out what this is in radians. right, so we know that this is pi, so I'm going to say this. Okay, we're talking about this right here. We're wanting to figure out what that is. So from here to here, that's pi. Now we have another, quarter of the pi, so this would be 90 degrees, so this would be pi over 2. So I'm going to write pi over 2 right here. And this will give us this value right here. Now, in case you forgot how to deal with fractions, which commonly, unfortunately, happens, the way you deal with it is that you see the denominator here is 2. We have to put a 2 down here to find a common denominator. We have to find some kind of number to relate it to. So we have to put a 2 down here. Now this number is pi right here, so something must go up top. We don't know what that something is. All right, but we have to have this value right here equal to pi, so there must be a 2 up top, because that 2 over 2 would just be 1, so then you get 1 pi, so it doesn't affect anything in that way. Now, in other words, there's really a 1 there too, in case you didn't see it. It's there, it's just in camo. It's hidden right there. So what we see here is that we have the common denominator is 2, so I'm going to write 2 here. And then how many pi's do we have? We have 2 pi plus 1 pi must be 3 pi. So this is 3 pi up top in the numerator. So this, in terms of radians, must be 3 pi over 2. So this would be 3 pi over 2 down here. So 3 pi over 2 radians. All right. So I wanted to talk about those values right there. Those are very important. Okay. Now, I also wanted to talk about, you see how we're going around this way? You think about a clock. The clock goes around this way. The clock spins this way. 12 o'clock, it's going. So it spins this way. So this way is going around counterclockwise, and these are all positive values. So this would be pi over 2, pi, 3 pi over 2, and then it starts again, it repeats, it cycles back through. This is 2 pi, and then it goes 0. Okay, so it goes like that. Now we can also reference it like this. Okay, so instead of going around this way, we can go around this way. And this way, we just say it's negative here. So instead of saying this is 90 degrees, we just reference this as negative 90 degrees. So this would be negative 90 degrees. This would be negative 180 degrees. This would be negative 270 degrees, or negative 3 pi over 2. And then this would be negative 360 degrees. We could go around the other way. Okay, so I also wanted to point that out. All right. I'm going to erase some of this, and I'm going to get into the next thing I wanted to talk about. So again, that's an important one to know, 3 pi over 2. This is an important one to know, that's pi over 2. All right. Radius of a unit circle is 1. Now, in context of trig, which I'm going to get into right away, once this is kind of erased here. Now, when we were in geometry, a lot of times we always think of the, SOHCAHTOA in terms of cosine and sine. Cosine and sine is actually a more general concept than SOHCAHTOA. It doesn't deal with, stuff with just, it actually exceeds angles, which are greater than or equal to 90, which I'm going to talk about right now. All right, so SOHCAHTOA is great and all, but this is what the actual definition for sine and cosine is. Okay. So if I take a value here, so call this angle theta. So I'm going to just call this angle right here. I'm going to call this angle theta right here. Now, if I consider that angle, here, I'm going to So if this angle is theta, it's always in reference from our initial side to our terminal side. If it's down here, it would be negative. If it's up here, it's positive. Now, this value for theta, we consider this point right here. Stab it right there. So this point right here. Again, this is the unit circle. This is 1, 0. This would be, 0, negative 1. This would be negative 1, 0. And then this value would be 0, 1. Okay. So when we talk about sine and cosine, this is how we literally define sine and cosine. I always just straight up define cosine to be, cosine is the x coordinate along any value for theta here. Cosine, you think of the x value. Cosine stands for the x coordinate. Sine will always, always, always be the y coordinate. Now, when we are looking at this value from here to here, what we define that point to be, when we talk about sine and cosine, if this angle is theta, this point literally is going to be defined cosine of theta, comma, sine of theta. So this point right here would be cosine theta, sine theta. So from this kind of idea, this is how we define cosine and sine. So if we're going to say cosine of pi over 2, if theta would be pi over 2, our x-coordinate for cosine of pi over 2 would be 0. So cosine of pi over 2 would be 0, because that is how it's defined. Also, sine of pi over 2 would be 1, because that is how it's defined. It's defined to be the y-coordinate. So this is how we define, these values for cosine and sine. So, okay, cosine is the x-coordinate, sine is the y-coordinate. Now, this is the theorem that I was talking about at the very beginning of the video, which I'm going to talk about right now, too. A very, very important theorem, right, states that for any value theta, it could be negative cajillion, that always, 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 sine of theta, okay, when we refer to this is kind of a weird notational thing that I want to talk about too, that instead of writing a lot of times in math, what we'll do is we'll put, parentheses around it and we'll write it like that to talk about it squaring the term. Well, that kind of, see how many parentheses there are around that? Instead of, to kind of get away from that concept, the way we can talk about squaring a term is just put the 2 up top instead of putting it over here in parentheses. So this is denoting sine of theta squared. So it'd be sine of theta times sine of theta. So this is what that stands for right here. So the theorem is that sine squared theta plus cosine squared of theta always, always, always equals 1. Well, we're talking about the unit circle. You see unit right here. You see the unit 1. The unit circle has a radius of 1. So if we were going to write a proof for this concept, we have everything we need right down here. If you consider any value for theta over here, and that this, we define cosine theta to be our x-coordinate and sine of theta to be our y-coordinate. If we consider the angle, so we're going down this way. If we take this and we take a perpendicular line from our point there, we say that's 90 degrees. We define that to be 90. All right, I'm going to erase this over here. I'm just going to move it over a little bit. So this angle right here is theta over here. So we define this angle to be 90. We know we can construct the line down here. This length from here to here, that length of that point would be cosine of theta. Now, if we look at our height, this length from here to here would be sine of theta. So from here all the way down, this must be sine of theta, because that's our height, that's our y-coordinate, that's how high up we are. So this is cosine theta, this would be sine of theta. Now we're given that the unit circle has a radius of 1, so this number right here is 1. So if we're going to try and prove this concept, we would have to prove that cosine theta squared plus sine squared theta equals 1 squared. Now, I also want to point out this. When I refer to length here, so if we're considering cosine theta here, this distance here, from here to here, this distance could very well, this could be negative. When I'm referring to here, distance can't be negative, but this value right here could be negative. In case theta goes around here, it could be negative. You could have that negative value over here. But we don't care about that because we're going to square the value anyways. So I want to stress that point first off. We don't care. We're going to square it anyways. It's still going to be positive at the end of the day. So when we're considering this length here, so we know by the Pythagorean theorem that cosine of theta squared, the leg squared plus the other leg squared equals our hypotenuse squared, so it's equal to 1 squared by the Pythagorean theorem. And this holds true for any value of theta, because even if it was negative for, our x-coordinate for cosine, we're going to square it anyway. So if we were going to consider that length, the absolute value of it, it doesn't really matter anyways. So this value, cosine squared plus sine squared theta equals 1 squared, is a very important result. It just comes immediately from the Pythagorean theorem, and I just wanted to talk about that. All right.